So in this video, we'll be covering a formula that is used to calculate the number of lone pairs on a central atom. So right here we have the formula. It is lone pairs equal to valence electrons, total valence electrons in the entire molecule, minus 8n. N is referring to the number of atoms on a central atom, right, over 2. So let's actually do nitro trifluoride here. I actually already did the steps, but I'll be pointing out to you exactly what I did, and then after that we'll be going over a couple problems, practice problems from scratch. So nitro trifluoride. So we know that nitrogen is in group 5, right? So the group number is also telling us the number of valence electrons, right? So that's why I actually have the periodic table here, so we can actually use it as a guide, right? So 5 nitrogen, right, plus 7 because fluoride is in group 7, right? It's a halogen, right? But there's 3 of them, so we would need to multiply it. So 7 times 3 is 21, right? 5 plus 21 is 26, so that's the total number of valence electrons. So we have 26 here minus 24. 24 is referring to the 8n, 8 just being just a fixed number, and n is the number of atoms connected to the central atom. And you could just tell just by looking at the molecule and it's how many atoms that the central atom is connected to. So NF3, we know that it would look something like this. There's 3 atoms connected to the central atom. So 1, 2, 3, right? So 8 times 3 is 24. So 26 minus 24 is 2. Over 2 is 1. So this number right here is actually just telling us the number of lone pairs on the central atom, right? So let's actually do one from scratch. Let's do BF3, boron trifluoride. Boron, if we happen to look at the periodic table, right, we know that it's in group 3, right? Group 3, boron. So let's actually go down. Let's figure out the number of valence electrons. So that's the first step, right? So 3 plus, we just established that fluorine is 7. So, right? But there's 3 of them, so it's 21. So 3 plus 21, this is 24, right? So in actuality, we would have 24 minus 8n, and just by looking at it, I know that there's 3 atoms, there's 3 fluorines connected to boron, right? So it would be 8 times 3, right? Which is 24 over 2. So we have 24 minus 24 over 2, right? So this is really, it comes up to be 0 over 2, right? Which is 0, right? So a lot of you might be asking, so 0, can we get 0? Yes, you can. So 0, remember, this number that you end up getting is telling you the number of lone pairs on a central atom. So if you get 0, that means that you don't have any number of lone pairs on a central atom, right? So we actually have, right? This is how it would look. Actually, it would look a little bit more like this, actually. More reticular planar. Right? Now, if you wanted to, actually, let me give that another color. Now, let's actually represent the lone pairs on the fluorines, right? So we know that there's 24 in total, right? Right now we have 6, right? We have 2, 4, 6, right? So we have 6. We can actually do 10, or 8, 10, 12, 14, 16, 18, 20, 22, and 24, right? And that's basically it right here. That's the total number of valence electrons. So that's how boron trifluoride would look, right? So just make sure that you actually know this, right? Because we want the each atom to have its octet, right? So boron is actually an exception. It can have 6 and be okay, but fluoride needs to have its 8 octet, okay? So that's the octet rule. So let's actually move on. Sulfur dioxide. Let's do this one real quick. So we know that sulfur is in group 6, right? Oxygen is also in group 6, right? 6. There's 2 of them, so it's 6 times 2, which is 12. So 6 plus 12 is 18, right? So we basically, let's actually I really love just drawing it out just to see, just to get a feel from how it's gonna look, right? So yeah, so we know it's 18, right? So 18 minus 8N, right? So there's 2 atoms that's connected to sulfur, right? There's 2 atoms, right? So it's 8, 2. So it's 18 minus 16 over 2, which is 2 over 2, which is 1, right? So there's basically 1 lone pair on sulfur. Let's actually move this down, and so we can actually get a better look of it. Let's do it that way. Let's actually redraw, make it look better. All right. Right? But let's actually give everything its octet before we actually move on. Let's do that real quick, right? We know that sulfur, we want to give it a full octet of 8, right? Right now it has 2, 4, 6. It has 2, 4, 6. So we can actually make a double bond here, right? That's actually giving sulfur 8, and we can actually just finishing off by leaving the electrons on the oxygen, right? And then we could double check that we have 18 in total, right? We have 18 in total in this structure. So let's actually double check that real quick. So 2, 4, 6, 8, 10, right? 12, 14, 16, 18. So we're good.